Some babies are born with a heart that does not work the way it should. And these small patients often face enormous medical challenges and serious complications. One of these heart conditions is hypoplastic left heart syndrome. And this is the condition we focused on in our research. In this condition, the left side of the heart is not properly developed. And this means that the heart cannot supply enough blood to the body. So how can doctors help these patients survive? Shortly after birth, they can place a small metal tube called a stent into the baby's hearts. And this can help maintain the blood flow to the body. This life-saving procedure stabilizes the newborn patients and extends the time until further open heart surgery is required. However, with the stent alone, the blood does not always flow in the ideal direction. And this means that some important organs, for example the brain, might not receive enough blood. In addition, the right side of the heart is under increased pressure, which could lead to long-term heart failure. And therefore, our goal was to develop small valves that can help control the blood flow in these small hearts. We integrated our small valve into a stent, which are used in the clinic already. And we tested if the valve is durable enough, how well our design works, and also if the interaction between the materials and the body is safe. To our knowledge, our small valve is the first valve developed specifically for newborns with this type of heart disease. Normally, heart valve implants are made for adults, and they are way too big to be used in newborn patients. Developing a valve at such a small scale is extremely challenging, and taking simply the heart valve implants used in the clinics and making them smaller would not work. Therefore, we used a biohybrid approach. We combined a stable synthetic material with a biologically inspired component, and this allowed us to create a valve that is both durable and well tolerated by the body. One really important aspect here is that the valve is in constant contact with blood. And if the materials were not suitable enough, this would lead to blood clotting and complications. Therefore, we paid special attention to ensure that our material is safe to be used in blood contact. We integrated the valve into a stent, which can be delivered using a catheter, a small tube. This means that our valve can be implanted without the need for open heart surgery. This project was carried out in collaboration with clinicians and also the company that produces these stents that are used in the clinic. And this ensured that our solution is both relevant and realistic for these patients. The current treatment approach using only the stents has been extremely successful so far and has helped many babies survive. At the same time, we see huge opportunities to further improve these treatments. Our results show it is possible to enhance these stents by adding a valve mechanism, and this helps improve the blood flow towards important organs. In the long term, this could mean fewer complications, fewer surgeries, and also a better quality of life for affected children. Of course, this work is still at an early laboratory stage, and a lot of further testing needs to be done before these valves can be used in the patients, as it is the case for all medical implants. In our laboratory, we are using this biohybrid approach for many other projects as well. This includes the development of small valves for children with congenital heart diseases, but also pediatric heart valves for children that can grow with the child, improved heart valves for adults, and blood vessels of different sizes. Ultimately, our implants should replace the animal-derived implants. Our goal is to see our ideas translated into real treatments that can benefit a lot of patients.